Okay, this is a spreadsheet that's the kind of thing I'm looking for in Lab 6. And first I want to point your attention up here in columns B and C in these top 6 rows here. First I have a value for M, and notice that value is just typed in. There's no formula for that, and it's the same for B, C, D, and sigma. And the idea is we're looking at a linear least squares model. And to get a linear least squares model, we need to make some assumptions. And what we assume is that two variables are related linearly, and the dependent variable is a function of the independent variable. And that function's a linear function. It has slope m, there's my m, and y-intercept b. Okay? And the goal of linear least squares regression is to estimate m and b. So that's what these values over here are. Okay. Now I've also got C and D, and what C and D are is that they are the bounds for the independent variable that I'm willing to consider. Okay. Usually when we're dealing with a linear model, we only want to think about certain independent variable values. For example, if you extend it too far, then your dependent variable becomes negative, and the vast majority of the time the negative values do not really make sense in the context of the problem. So all of our x values that are generated are going to fall within this range between 4 and 14, and we'll see that if you look down here. I've got a 12, I've got a 13.2, but they all fall between 4 and 14. I got a couple 4-point somethings at the bottom. And then finally we have sigma, and what sigma is the standard deviation of the y values for a particular x value. So we have a linear relationship between x and y. However, the y values are only centered at that point on the line for the x value, and then where they actually fall is determined by a normal distribution with standard deviation sigma. Okay, so you'll need to pore over the directions of the lab, try to figure out how to get these values. These 5, again, we just type in, and I can change it. There's nothing special about the values I have here. You can choose any ones that you want. It makes sense to make sigma relatively small with respect to the y values that are going to occur. Maybe my slope is a little bit smaller and it becomes 0.9, etc. And what this spreadsheet should do is, first of all, it should generate some random data. Okay, and the first values are these x values, and the x values are the independent variables. And what they are, they're random numbers between, in this case, 7 and 14. Okay, so to get a random number between 7 and 14, what I do is I start at 7, so I could type equals 7, plus, now I'm going to use the rand function. If I use rand and put parentheses with nothing inside of them, what that does is gives me a number between 0 and 1. I think we've used that before in a lab. That by itself would just give me a result between 7 and 8, because I'd be taking 7 and be adding a number between 0 and 1. But I want a number between 7 and 14. So what I'm going to do is multiply by the difference between these two. Well, let's make this 13 instead. Whoops. Let me just hit enter. Stop that one. Let's make this 13, and the reason for that is the difference was 7. I didn't want to get you confused on the 7s. And I can multiply the rand by 6. So I'll take 6 times the rand, and what that does is it gives me a random number between 7 and 13, because I take 7 and then I add 6 times the number between 0 and 1. So I'm taking 7 plus a random number between 0 and 6. Now when you do that, obviously you'll want to use cell references, so that indeed if you change one of these, then your x values indeed change according to that range. If I started at 0, I would have some smaller x values here. This one's really close to 0. Okay, so that's how we get the x values. And then for the y values, the y is the result of a random variable that is normally distributed with mean. Actually, this should be changed, and this is correct in your handout. Had it wrong here. It's mean m times x plus b, and standard deviation sigma. Okay, so y equals the result of a random variable that is normally distributed with mean m times x plus b. That times looks sort of ugly and isn't helpful since we don't actually need it to calculate it. M times x plus b and standard deviation sigma. So let's suppose you wanted to get an output of a normally distributed random variable with mean 23 and standard deviation 0.4. Okay, we've done this before, but I want to remind you how it works. What you use is the norm inverse function. Okay, and three inputs go into the norm inverse function. First of all, you need probability. We're just going to put that rand, and that's the value for the cumulative this cumulative distribution function that you want it to have. We haven't talked about cumulative distribution functions, so I'm just going to have you put rand in there. And then for the mean, you use the mean of your random variable, and then the standard deviation, you use the standard deviation, of course. Okay, if I do that, it'll give me a number fairly close to 23. Okay, and if I recalculate it a bunch of times, we see that indeed it does give us numbers that are usually close to 23. Okay, so that's how we'll get the y values, except again, you want to use cell references instead of exact numbers in here. And then finally, the whole point of this lab is to show how linear least squares works. Now, to estimate the slope and the y-intercept, you have some formulas in your text. And they're formulas that you might have used before in class, especially if you've taught this stuff. Use those formulas to come up with the estimates for the slope and the y-intercept. You might have to work with this data some more, make some new columns, etc. But your ultimate goal is to get an estimate for m and b according to this data. Not looking back at what m and b actually are, but according to the data. And you'll see that the estimates tend to be pretty good, but not great. And that's the case for this sample size of 30 that I have here. The estimates tend to be pretty good, but not great. All right, so good luck, and please do let me know if you have any problems.